So now that we've looked at how to draw Lewis dot symbols, so symbols of elements with dots for valence electrons, we're now going to put these atoms together with their valence electrons and make compounds. So we're going to show we can take a formula of a compound and draw a structure. So what's bonded to what? So we've seen that covalent compounds, also called molecules, will share electrons when they make a compound, and those the electrons that are shared are valence electrons. So when they share electrons, if they share 2 electrons, that's going to be called a single bond. If they share 4 electrons, it's going to be called a double bond. And if they share 6 electrons, it's going to be called a triple bond. In some cases, in a lot of cases, there's going to be some valence electrons that aren't part of the bonding, but exist only on one atom. And those kind of electrons are called non-bonding electrons because they're not part of the bonding. And we have a specific name for them if they're in pairs, and they're called lone pairs because they're not part of bonding, they're just sitting on one of the atoms and not the other atoms. So again, there's a whole bunch of different types of covalent compounds. Bonding or determining the structures are going to be very similar in all of them. We're going to do this with kind of simple compounds where we have a central atom and things bonded to it, so we can follow a set of rules. But then we'll look at molecules that are a little bit bigger and kind of see how to deal with those. So there's basically 5 rules when you have Lewis structures for compounds or molecules that have a central atom. So a central atom and then things just bonded to it and that's it. So the first thing you want to do is look at the formula and figure out how many total valence electrons that molecule has. Okay. Second, we want to draw the skeletal structure. And the skeletal structure is simply the central atom with one bond, a single bond to each other atom. Okay. Third, we're going to distribute any leftover electrons around the outer atoms, not the central atom, the ones on the outside. They're also called terminal atoms. Any extra electrons after we do that are going to go on the central atom, and then we're going to do some things to make sure it's the right structure. Okay, so let's look at an example here. We have CCl4. That's carbon tetrachloride, right? It's a binary compound, a binary molecular compound, or binary covalent compound. So we would name it with the prefixes. So carbon, because there's only one and we don't put mono in the first. Cl4 is tetrachloride. Okay, we have to count the valence electrons. Carbon has 4. The halogens, which is where chlorine is, they each have 7. So there are 4 chlorines though, and each chlorine has 7 valence electrons. So carbon has 4 plus 4 times 7, because there's 7 for each chlorine, but there's 4 chlorines. So 4 times 7 is 28, plus 4 is 32. So we have 32 electrons that we have to put in this structure that we're going to draw. Okay, and then it says draw the skeletal structure. Skeletal means I put the central atom, and I put all the other atoms around it, and I put one bond between each of them. So when we do that, we put the pair of electrons so it exists kind of like that between the 2 atoms. Okay? A modified version of this is when you have a bond, we draw it as a line. And a line means 2 electrons because a bond is 2 electrons. So the other way to do this would be drawing like this, where that line means that's a single bond and that's 2 electrons. So I'm going to do it that way because that's typically the way we do it in chemistry, where bonds are shown as lines. Okay? A double bond that has 4 electrons is going to have 2 lines, but we'll get there. Okay, so that's our skeletal structure. Now we have to distribute the electrons around the outer atoms. Okay, so we started with 32 electrons. We used 2, 4, 6, 8 to make our bonds. So 32 minus 8 is, we still have 24 electrons that we have to put in the structure. Okay, so we're going to distribute electrons around the outer atoms. Most atoms will get a total of 8 electrons. Okay, so that those shared electrons in the bond count for both atoms. So right now, that chlorine has 2 electrons around it. Okay, each of the chlorines does because they each have a bond. And we count those electrons that are shared for both atoms. Okay, so right now each of the chlorines has 2 electrons because of the bond. So now we're going to give each chlorine 6 more electrons by drawing 3 lone pairs. Remember, lone pairs are pairs of electrons that aren't bonding, but they exist on one atom. So I'm going to do that for each of these. So each of the chlorines is going to now have 8 electrons around it. 6 of the electrons are in those lone pairs, and then there's the bond, which is 2 more electrons. So notice the carbon, since it has 4 bonds around it, has 8 electrons around it. So the shared electrons count for both atoms that are bonded together. So when we did that, we used 6 electrons for each atom, and there were 4 atoms. 6 times 4 is 24. So there are no electrons we need to put in there. So if we want to count them, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. There's 32 electrons in there. Okay? So the other thing would be step 4. If we had any more electrons, they would go on the central atom. But we don't have any more, so there's none to put on there. And then the last thing is we want to determine if the central atom has an octet, if it's got 8 electrons around it, if it wants an octet. We'll talk about times when it doesn't. But carbon is one of those that would like an octet, and in fact it's got 4 bonds, and each of those bonds have 2 electrons. 4 times 2 is 8. So there's 8 electrons around that carbon. So that structure we just drew is the correct structure for carbon tetrachloride. Let's do a couple more as practice. Okay? Following our 5 rules. NH3, that's ammonia, not ammonium. Ammonium is an ion with 4 hydrogens and a positive. We can do that one here in a second too. NH3 is ammonia. Step 1, count the valence electrons. Nitrogen has 5 valence electrons. Each hydrogen has 1. So 5 from nitrogen plus 3 hydrogens times 1. So 3 times 1 is 3, plus 5 is 8. So this structure has 8 electrons in it. Draw the skeletal structure. Nitrogen with 1 bond to each hydrogen. And you can put these hydrogens on whatever side you want. I'm just doing it like this. Okay. So to do that, we use 6 electrons, right? Because each bond is 2 electrons, and there's 3 bonds, so 6 electrons. So that means we have 2 electrons left to put in there. Hydrogens are only going to take 2 total electrons around them. So basically a hydrogen with a bond is done. Remember, hydrogens only have 1 proton. So trying to put 8 electrons around it isn't going to work because there's not enough attractive forces there. Okay? So the hydrogens, once you've got a hydrogen with a bond, it's done. We're not putting any more electrons on those hydrogens. Okay? Which means they're always terminal. I mean, because you can't put a bond on one side of a hydrogen and then put a bond on the other side. You can't do that. Hydrogens get 1 bond and that's it. So we have 2 extra electrons, and those extra electrons are going to go on the central atom, the nitrogen, like that. We want to check to make sure the central atom has 8 electrons around it, because nitrogen is one that follows the octet rule. It wants 8. So we can see we've got 2 in this bond, 2 in this bond, 2 in that bond. So that's 6 electrons in bonds, and that lone pair is 8. So there's 8 electrons around the nitrogen. So we're done. That NH3 looks like that. Okay, CH2O. and carbon is the central atom, meaning all those atoms are bonded to carbon. Let's count the valence electrons. Carbon has 4, plus we have 2 hydrogens that each have 1, so 2 times 1, plus oxygen which has 6. So 4 plus 2, which is 6, plus 6, which is 12. So we have 12 total electrons. Draw the skeletal structure. Carbon, oxygen, hydrogen, hydrogen. Okay. Carbon central, everything's bonded to it. Skeletal structure shows the central atom with 1 bond to each atom. Just like that. That took 6 electrons. So we have 6 left. Okay? Hydrogens are done. They get 1 bond and that's it. We got to fill the outer atom with an octet. We want to give oxygen 8 electrons. It's the outer atom. Remember, carbon central, so we don't deal with that until the end. So basically, we're going to give the oxygen 3 lone pairs, just like that. So we can see now that oxygen has 8 electrons around it, 2 in the bond, 2, 4, 6, 8. 3 lone pairs. So we use 6 electrons to do that. We've got all the electrons in there we want, that we can have. That's all of them. Okay. So oxygen has 8 around it, which is good. Each hydrogen has 2 around it, which is good. Carbon would like 8. Carbon would like an octet. So right now, carbon only has 2, 4, 6, because that's the 6 in the bonds around it. We need to share another set of electrons with carbon, but we can't put any more in there, right? Because we've got the 12 valence electrons that we have. So what we're going to do is take a lone pair and share and move that lone pair from the oxygen, that's only on the oxygen, into a bond and make another bond with carbon. And when we put another bond with carbon, those electrons are now shared with carbon and carbon sees them. So when we do that, we get carbon, now with a double bond to the oxygen. That oxygen now has 2 lone pairs on it because we moved one of the lone pairs in for a double bond. A hydrogen and a hydrogen. Okay, now if I look at the oxygen, it's got 4 electrons in the 2 lone pairs, and it's got 4 electrons in the double bond. So around oxygen, there's 8 electrons around oxygen. Around the carbon, there's 4 bonds, 4 times 2, because there's 2 electrons in each bond. There's 8 electrons around the carbon. So that is the structure, the Lewis structure for carbon. Basically, carbon has a double bond to the oxygens and single bonds to the hydrogens. Let's do one more. NH4+. I want to do an ion. We're going to do some later on, but let's do one now. NH4+. That's NH4 that's all bonded together covalently and has lost an electron. Lost a valence electron. So let's count the valence electrons. 5 for the nitrogen, 4 times 1 for each of the hydrogens, minus 1 because we lose 1 to make it positive. So 5 plus 4 is 9, minus 1 is 8. So we get nitrogen in the middle, bonded to each hydrogen, as we're drawing the skeletal structure now. Just like that. How many electrons did we use to do that? 2, 4, 6, 8. Because there's 4 bonds. There's 2 electrons in each bond. So 8 total electrons there. So we've used all the electrons we have. Notice nitrogen has 8 electrons around it because it's got 4 bonds, 8 electrons. So this is right. The only thing I'm going to do is when we have ions, we put brackets around it and put the charge in the upper right corner. That way when I look at it, I know it's an ion. I know that structure is missing 1 electron because it's positive. So 1 electron is left. So whenever we have a polyatomic ion that we're drawing the structure of, we put it in brackets and put the charge in the upper right corner. That's showing the reader that's an ion and what the charge of the ion is. Okay, that's it for your introduction to Lewis dot structures. We'll do some practice a little bit later.